All right, we're going to quality of life. There are 26 items, and they are summarized into 4 domains. Domain 1, physical, psychological, social, and environment. Some questions are worded negatively. So how they do it? They add up the responses for domains for the item each domain. They sum it up for each domain, right? Before that, let's do a frequency. You want to see any missing values, out of range values. So go to analyze, descriptive, frequencies. So bring all the Q items and just click OK. Okay, first table is important. It tells you any missing values. Look at the second column, second row. There's no missing values for any of the items. That's good. We expect that when you do Google form, because you don't answer one question, they can't move on to next. And here you can see that this is the scores. For this, no score 1. Here complete 1 to 5. Here only 2, 3, 4. Okay, don't have the 1. And just browse through. So these are responses given. So it looks like there is a spread. Supposing everybody answered number 3 means there's no spread. Everybody said the same thing. Supposing this response came like this, right? This response came like that. That means that everybody answered 3. It's not of use. We want the spread for the responses. All right, that's done. Let's do the scoring according to this scoring given to you. So go to transform, compute variable, compute variable. Let's follow what are given there. Domain 1, domain 1. So here, you will sum the values. So first one is 6 minus Q3. Why 6 minus maybe ours not Q3, ours is QL3. 6 minus QL3. Why are we doing this? Supposing a person's response is 1. What will be this?
5.
Response 1, answer be 5, right?
Yes.
The another person answers, let's say now we have, okay, these people 1, 2, 3, 4, 5, any of the responses. What is 6 minus 1?
5.
Because 6 minus response, this will be 5. What will be 2?
4.
4.
3?
3.
3. 4?
2.
2. 5?
1.
1. So that's called reverse coding. Now 1, 2, 3, 4, 5, we coded at 5, 4, 3, 2, 1 by this particular formula. Okay. So first one is that. Then plus what? 6 minus? 6 minus?
QL4.
QL4. So after that, no reverse coding. 10 plus 15 plus 16 plus 17 plus 18. All right, close bracket. Okay, close bracket. Sorry, no close bracket. No close bracket. So 6 minus that, 6 minus this, all these add together. Click OK. In the data editor, look at the last column. Look at the last column in the data editor. So that's domain number 1. Right. That's domain number 1. Are we clear?
Yes, Prof.
How many items you added? How many items in the particular domain? How many items?
7.
7 items. 2, 3, 4, 5, 6, 7. So what's the maximum score possible? Maximum score possible?
35.
35. Minimum score?
7.
Minimum score?
7.
7. So in your data, the maximum must be, how much? 35, right? 35, minimum is 7. So all are within the range. Okay, now you do for the domain 2, 3, and 4. Continue, domain 3 and 4. 2, 3, 4. So I can correct here also. Now this 5, 5, this is 6, 7, 11, and 19. The last one, 6 minus 26. X, domain 3, 20, 21, 22. And the last one, 8, 9, 12, 13. Okay, so we are done. So what's the minimum, maximum for domain 1?
7.
7. Max is 35.
Right, domain 2?
6 and 30.
Right, next one.
3 and 15.
Okay, next one, right? Okay, let's see whether they are in the range we have. This data, this variable, are they quantitative or qualitative?
Quantitative.
Quanti or quali?
Quanti.
Quanti. Okay, let's think. Analyze. Descriptive statistics. Explore. So check it out. The last 4 variables. All right. You want test normality is fine. Okay, normality. Click OK. All right. Domain 1. What's the minimum, maximum? Domain 1, what's the minimum, maximum?
11 and 35.
Right. Is it within the range?
Yes.
Within the range?
Yes. Yes.
Next one, 11 to 30. Next one, 5 to 15. And last one, 19 to 29. And we have the respective mean values and everything. Unfortunately, that's not the end of story. There's only raw score. You transform this to use this transformation. All right. For this domain 1, which is physical, score 1 we will transform to 0. power 8 transformed to 6. Example in your data. Okay, for the domain 1, the 31 we transform to what? Look at 31. 31 will become what?
88.
88. It's not just one transformation factor, okay? So this 88. Next one.
81.
Look at this raw score and it's transformed to 0 to 100, upon 100%. 0, 4 to 20, 0 to 100. So we take the 0 to 100 transformation. Then it's a percentage like 50%, 60% or somewhere, right? Okay, next one. What's next? 30. 30 will be
81.
81.
81. Next,
44.
44. Can you do this? Can you do this?
Yeah.
Yes.
No problem, right?
You can.
Recoding, changing all the values, no problem, right?
No problem.
No problem. But do you want an easy way out?
Yeah.
Yes.
Yes, right? How many want the easy way out? Nobody wants.
All of this.
Don't say all of us, okay? Don't represent all of us. I want a chorus. How many of you want the shortcut? Nobody wants. Okay, then I won't give. Okay, going to skip that. Again, how many want?
Me.
I want.
Okay. Right. So I'm going to send you the syntax. We're going to use the syntax. I'm going to WhatsApp to your leader. We'll send you. Initially, I didn't give you because I wanted to calculate manually. Now I feel very generous, a bit generous. So I decided I'll give you the syntax. But that's how it's done. Okay, who's the person? So what's the number, the leader? 1 for what?
In the group.
Is it 1 for?
No. Could you go down, Rolf? Yeah, in the QOL research group. Yeah.
No, I want to send everybody. Can you send to others? Will I send you?
Oh, yeah. Okay, I'll forward it to the class.
Okay. Now it's meant for all of you to do, okay? Because end of the day, I want you to submit. QOL syntax. The class reps.
Scroll down the one with 93. Yes. This one.
The color. Okay. Forward to all the students. Okay. Okay, open the syntax. Are you all here?
Yes.
Yes,
Right.
Prof.
See here, I already mentioned how they are recorded. After recording, sum it up, right? Use function, sum it up. And then how to convert them from raw to percentage cost, and then how to measure describe the values, and how to examine these values, right? Okay, maybe here remove this, but leave it, right? Okay, so data is there. It's a data file. Okay, so that's a data file. We don't have to do this. Let's clear the whole thing. Instead of doing manually, we want SPS, the syntax to do for us. Okay, let's go to syntax. So this is a syntax. Run all. Run all. Okay, look at the output. Okay, look at the output. The final score there. Let me run again. Let me run again. All right. Ultimately, what I wanted, the score upon 100, right? So this is a final score upon 100. It's been calculated, transformed, and given you. So what's a mean score for physical, mean score for psychological, social, and environment? Right. All these upon 100. Median score, this is a median score, meaning at least 50% of the respondents scored more than the respective values. So how do you compare all the four? How do you compare these four? They all may standardized 0 to 100. Remember, some items, 7 items, some domains, 7 items, some 3 items. So the range will differ. But now we already have standardized upon 100. So how do you describe this course now? Is there any differences between the domains? What do you think?
Psychological score is the highest, whereas the environment is the lowest.
The worst. But do you think much difference between the first three?
No,
Not much, right?
no.
Generally, what you see, environment is low, right?
Yeah.
Yes.
Right? So that's a minimum maximum scores. Minimum maximum scores. So it can be as low as 19 upon 100. People also scored maximum 100. Okay? And this is Skinner's values, Kurtosis values. Later see why it's important. So now, test the normality. The result shows all are not normal, less than 0.05. Is more than 0.05, we say distributed normal. Otherwise, it's a less than. And then look at the box plots. There's no extreme values. No extreme values. All right. All right. So even though data is not normal, okay, even though this data is not normally distributed, we can still argue there is some evidence of it being fairly normal based on the Skinner's values, Skinner's and Kurtosis values. What do you do? This divided by this, Skinner's divided by the standard error. Skinner's divided by standard error. Is it less than 1.96? Is this value less than 1.96? Is value less than 1?
Yes.
Is it less than 1.96 this over this?
Yes.
Yes.
What about here? They want yes or no?
It's less. Yeah. It's
Yes.
less.
What about here?
Yeah.
What about here?
Yeah.
Yes.
Right? So we can say they are fairly normal. I'm going to bring these values into SPSS and sorry, into Word file. So I'm going to transform this, double click, pivot, pivot, transpose. So become, these are the domains and these are the scores. So the decimals, too many decimals, maybe 2 decimals enough, or I can do manually, okay? All right. So copy this table and go to Word file and paste it here. All right. The scores, the final scores in each domain are shown in, let's say, call it table 4. Table 4, descriptive summary. The domains. Okay, domains of QRL. Again, we don't need this. So mean. So normally we express mean plus or minus standard deviation. Right? Mean plus or minus standard deviation. That is 16 point. Okay, 16.37. So do the same thing for the rest. .55. All right. So you remove this column. Normally mean plus or minus standard deviation. It's okay to show the median as well. Right? Some people like to interpret what's the cutoff point for the 50th percentile. It means what? At least 50% of the respondents score less than 63. We don't emphasize high, we don't emphasize low. That means at least 50% are below 63, 69, 69, and 56 for the respective domains. Okay, so once you've taken this, we don't need this. Right? Skewness, standard error, SE, and put here Z value. So this divide by this, put a value here. Put here skewness, because often they ask you whether data is it distributed normally. Skew divided by SE. So this divided by this, place it here. How much is it? How much?
0.5.
0.5. Doesn't matter positive, negative, okay? 0.5. Next. At least 2 decimals.
1.17.
1.17.
0.08.
0.8.
1.33.
1.33. All right, so I don't need all these columns. Okay, they're showed here. Table 4. The mean scores, the mean scores for the scores were there, right, comma, whatever, for the physical, psychological, physical, psychological, social, and environment domains. The skewness divided by ST values of all skewness values for all the four domains were less than 1.96. Hence, the data distributions are fairly normal. It's not perfectly normal, fairly normal. Again, all the tables must follow the same font size and everything. Now, this is important because later you want to compare against the demographic, and the question comes whether they were normally distributed or not. If normally distributed, we can do parametric test. Otherwise, must perform non-parametric test. But in this case, we have sufficient evidence to say that the distributions are fairly normal. All right. Okay. So first part, here what's the objective? Quality of life group, what's the objective? Objective?
Assess the quality of
To
life
assess
among
the
the
quality of life. So objective to assess the QOL, blah, blah, blah. So now I'm telling how, what question I used, how many domains, how the items measured, a response of 1, and then some were voted negatively, and this is the final score. This is objective number 1. So what's objective number 2?
to explore if there's any relationship between the quality of life and social demographic
Right. To determine the association between QOL and demographic characteristics. Right. Demographic characteristics. Anything else? Any other
maybe
objective?
relationship between the different domains, if there's a correlation.
Right. It needs to compare. To compare the differences between domains of. First, now it's already there. We don't need this. We'll talk about this. In fact, I already mentioned here, you already have this. I already put all the values here. At the end of the day, you can say quality of life in each domain, and domain 3 is a bit lower compared to other domains, right? So we don't need that second objective. So determine the association between QL demographic characteristics. Group number 7. Group number 7? Who's group number 7? Group number 7, QOL and happiness.
Yeah, doctor, it's us.
So what's your objective?
Our objective is to see the relationship between QOL and happiness, and also to see which domain influences happiness mostly.
Right. So your objective will be similar, right, to assess the quality of life. Number 2, to assess the level of happiness. And number 3, to determine the association between QOL and happiness. So this will be your objectives. Unfortunately, this group, the QL group, is very unfortunate because people are borrowing from there and they don't have much other objectives, right? So you're measuring level of happiness. Now, who's measuring happiness? There's one group, happiness alone, right? Who's measuring happiness alone?
My group, Prof.
Okay, what's your objective? To assess level of happiness, right?
Yes, Prof.
Level of happiness. Next, between happiness score and demographic characteristics, right?
Yes.
Demographic characteristics of the respondents. See what you already done QOL. These two groups going to use QOL, and then this group happiness, and later you do happiness with the others. Mental health will be totally different questionnaire. Health seeking behavior. Okay. So done for this group totally, obesity group. Obesity group, you've done the first objective. What's second objective? Obesity group, what's the second objective? Obesity group, what's the second objective? It was obesity group. It was obesity group.
To see the association
Oh,
of
obesity, sorry. Quality of life. Sorry, I made a mistake. Okay, QL group. Let's say first objective, you're done. Then you make comparison, then compare. Right. What's the next objective?
To compare to find association between quality of life and the demographic factors.
Right. Again, going to use the same demographic. So establish a demographic is very important. After that, you just go on. So this is number 2, association between QOL and demographic characteristics. Okay. All right. So what test will be doing? What test will be doing? Now we have in a data set, we added these 4 variables. So I can bring the variables closer, easier for me to see. Okay, this. Now after I've done this summary, I don't need the original values anymore. I can delete these values. I don't need this anymore because I already done the summary. So data file become much simpler. So the group does not do happiness. In fact, and delete others as well. So I can't delete this and why? Clear. All right, I don't need the original questionnaire anymore. All right, so bring it up. Bring this for close the demographic so that I can see what I'm looking for to answer my second objective. Okay. So that's your scores and this demographic, right? Bangsa, tahap pendidikan, and all these things. Let's move this. Okay. So I'm going to use Bangsa 2 because I already removed the Sabahans. So I have, is obesity important for quality of life as well? Is obesity important, relevant for quality of life?
Yes.
Yes, they can add on. So I'll take the obesity thing. So you want to compare example, environment, obesity. So what test will you use? What test?
Test.
Huh? This Jantina, right? Gender and environment. What test will you use? They're testing the mean difference, right? What test?
Chi-square.
Chi-square. Chi-square for qualitative variables. Here one quantity, one quality. This quality, how many levels are there? Male and
2.
female, right?
Yeah.
So we do independent samples t-test. Later, obese 3, how many levels are here?
3.
3 levels. Therefore, for this, we'll do one-way ANOVA. Are we clear? Are we clear?
Yeah.
Right. So this association between these two, so we're going to have different analysis, maybe different groups. So bring this. All right. We can either do one domain per table, or all 4 domains into one table. So I'm going to do all 4 domains into one table. Let's call table 5. Right. Association between your L domains and demographic characteristics were tested using t-test or one-way ANOVA. Okay, one-way ANOVA for more than 2 groups. Example, Malay, Chinese, Indians. 2 groups, male and female. All right. Second to all 4 in one go. So first one is physical. Second one, psychological. Next one, social, and last one, environment. Currently, we won't have this. Okay. Let's do the first test, the t-test, the 4 domains, and gender. Are we ready?
Yes.
Yes.
Right. Analyze, compare means, independent samples, t-test. The variables are these 4 test variables, grouping variable, Jantina. I said define groups. How is mine defined? Definition, right? It's not numerical, either perempuan or lelaki. So define groups, type exactly, okay? Capital means capital, perempuan. Number 2, lelaki. This is how they are defined. Okay? So bring the 4 variables in, bring Jantina, clearly define. How are they defined? These are wordings here. They are string variables. Type there, continue, and click OK. Right? Long string variable. Perempuan is very long. Okay. This says this variable is very long. 37, okay. So I got to recode this. I'm going to open a column beside. All the perempuan, I'm going to make it as 1. All the lucky as 1. Okay, this 1, because sample size small, I can do this. Large sample size, I use some transformation. And this is 2. So always better to define variables numerically. So what's 1? What's 1?
Okay.
All right.
Honestly, okay.
Let's do this again. Get out. Put in this variable. Define groups. Let's say 1 and 2. Click OK. So now we have the mean values for all the 4 domains by male and female. And whether significant or not, look at the next table. Now this is testing whether variances are very similar. P-value more than 0.05, so the variance are similar. This is not. The variance similar, we can do a parametric test, which is the first row. Variance not similar, normally we do non-parametric tests. But here, let's say we go ahead all parametric. Right, so here variance similar, this for testing variances, but I want to test means. So variance similar, you follow this row, you come to this p-value. This p-value is it more than or less than 0.05?
Still
Yeah?
less than 0.0.
What does it mean?
Significant.
It's
There
significant.
is a difference between the groups. How about others? Any difference?
No.
No difference. So only difference is physical between male and female. How does it differ? Look at the group. Who's higher, male or female? Male or female, who's higher?
Female.
Females are better off physically, right? So physical, what's the value there? For male,
60.
yeah,
60.8.
60.8 plus minus standard deviation. Plus minus how much?
13.6.
13.6. Okay, 13.6. Right. Female?
67.5.
0.5 plus minus
16.7.
16 point. Okay, plus minus 16.7. Okay, type the whole thing until end. Okay, you want to still have p-value below that or bracket p equals to, so what's the p-value for the first group? 0.037. To tell that there's a difference between these two groups. Obviously, this is higher compared to here, right? All this no difference, right?
Yes.
All right, just put in the values, that's all. Type in the values.
But for the ones that there is no difference, that is the last three, do we still put in the p-value?
Still complete the table. Below that, put the p-value.
Okay.
Below that, the p-value tells that this is what the means were, and it's not significant, 0.836.
Okay.
Are you done?
Yep.
Okay, next one is marital status. How many levels do you have marital status?
3.
Where's marital status? 3, yeah. Okay. Yeah, deleted marital status. Do you have marital status? Do you have the marital status in your data?
No.
Huh?
Wait, yeah, we do.
How many levels? How many levels we have?
4.
4
There's
levels. 4 levels. What analysis will you do?
One way.
Yeah. One way,
Yeah, ANOVA.
ANOVA. You try the one way ANOVA for that. Analyze, compare means, one way ANOVA. Again, all 4 variables. And the factor, I don't have that, so I'm going to put obese. Oh, I deleted some of the variables. Right, do you have that? Do you have marital status here?
No.
Can you bring marital status inside?
No.
Have or not? Yeah?
It's not
Do you see
there.
marital status here? Do you see obese 3?
Yes.
Yes. How come Bangsa do you say?
Yeah.
Then why can't you see marital status? Because marital status is not numerical. This can use only numerical variables. Right? There's the schooling, the school, Taha Pendidikan. Is it inside here? Is Pendidikan here?
No.
Why not? Because pendidikan, look at the pendidikan, it is a string variable. It is a string variable, this cannot be used. One way another cannot be used. Are you following?
Yeah.
Yes.
Either change them into numeric, or the lazy to do this, you follow this analysis. Analyze general linear models, multivariate as an alternative. You don't have to go and redefine the variables. Basically, I'm doing ANOVA because the predictor variable is string variable. I can't use this ANOVA procedure, right? I can't put in the factor. Let's try here. Do you have marital status here? Do you see marital status? Class, answer.
No.
No.
Oh, yeah. What happened to marital status? Never mind. Tahap pendidikan. Do you see tahap pendidikan?
Yeah.
Yes.
Okay. Put into fixed factor, which we could not do here, right?
Yes.
Because tahap pendidikan is not numeric, right? See, it's not defined, it's not numeric. So now put the 4 variables in, right? I could even put gender here, okay? Doesn't matter. I'm gonna put gender here, right? I can put obese 3 here, can. Here I can put obese 3, but I can't put tahap pendidikan Y. Obese 3 is defined numerically. This ANOVA takes only numerical variable here, right? But here it can be numerical, can be non-numerical. Are you with me?
Yes, Prof.
Yes.
Right. Then what do you do? Now, do you see EM means?
Yes.
Your button EM means?
Yes.
Yes.
Okay, click that. I don't want that, right? Sorry. Go to options. Options. Under option, do you see descriptives?
Yes.
Yes.
Click that. Under option, click descriptive. That's all. Click OK. Right. So these are the descriptive statistics. Physical for the range of level of education. Same thing here and same thing here. Now, what I want to know is whether the physical score does it differ by level of education. So go down. I mean, a lot of tables, don't worry. Right. So we have tahap pendidikan. All the values are only follow this. Other variables you follow in tahap pendidikan. Are they all significant?
Yeah. Yes.
Right? All the 4 values are significant. Tahap pendidikan. So this value 0.012. Next value is the p values, 0.001. Next one. I mean, there are many ways of presenting this. I think this is easier to understand. And the last one. Okay. What does it mean? And then what do you do after that? You insert all the mean and standard deviation values. After that, you take this table. Right, so these are the values. Remove the total. Okay, these values, you're going to take it up and fill up. Example, for physical Kalau mendengar, standard deviation, right? So these values will go into this table. Example, 67.57 plus minus 16.43. Let me do one, okay? Next one, 72.08 plus minus 14. Are you with me?
Yes.
Yes,
Yes.
Prof.
And the last one, 59.06 plus minus 14.59, right? 14.98. All right. So what does it mean? Just now, this p-value was less than 0.05. We say there is a difference between male and female. Now here, what's the conclusion? What's the p-value here now? What's the p-value here?
0.0.
So what does it mean?
That there's a difference between the
Between
and the
Gender.
genders.
male and female. Here, what's the p-value?
0.012.
What does it mean?
There's
There is
a
a significant difference.
Difference
between the education levels.
between at least one pair. This only one pair. There's a difference. Finish. But here, difference between at least one pair, either primary and secondary, primary and tertiary, or secondary and tertiary. The three-way possible, right? Only one way, one pair. Here, three pairs. Obviously, which pair must be different? Obviously, which pair must be different?
Tertiary and primary.
Tertiary and
Secondary, sorry.
secondary must be different. One pair. How about tertiary and primary?
Yes.
Yes.
We don't know, right? That's why we need a post hoc test to see who is different. Are you okay?
Yes.
All right. Let's do that. How to do that? Go back and listen again. Recall multivariate. Now, why doing multivariate? Why not ANOVA? Because these variables are not numerical. They are string variables. SPSS for ANOVA takes in only numerical variables. All right. Multivariate. After knowing there's a difference, we want to know which pair of pairs are different. We're going to do a post hoc test. There's a post hoc, right? Tahap pendidikan. And there are so many tests can be done. So for this exercise, let's use Tuki. Post analysis, knowing the difference. We want to know which pair of pairs are different. So we do the post hoc for this variable tahap pendidikan. We don't do for theta, two groups, because we know there's a difference. Okay. Continue and click OK. Right. Scroll down, post hoc test for all these variables. Or can use the second one, homogeneous subsets. This one is very confusing, a lot of asterisk sign and everything. Look at the homogeneous subsets. These three groups, they go into two subsets. If all three are different, there will be three subsets. If no difference between three groups, be one subset. That means three went into two subsets. Who is subset one, but not in subset two?
Tertiary.
Tertiary is subset one, but not in subset 2, right?
Yeah.
Yes.
Scholar render, not in subset 1, but in subset 2, right?
Yes.
But this can go into either way, right?
Yeah.
Yes.
The subset 1 and subset 2. So what is subset 1? It is tertiary. What is subset 2? It is coloranda. That means coloranda differ from tertiary. Coloranda differ from tertiary. Is it correct? Is this coloranda? This value?
Yes.
This wrong, is it?
Yeah, actually, yeah, 72 is supposedly primary.
Primary, okay. Move it up. All right. So these two values are different. What about this? This does not differ from either primary or secondary. So, or tertiary. Primary does not differ from tertiary or, sorry, secondary, does not differ from tertiary or primary. The difference is between these two. Right, we say the significant difference. How to say that this and this are different? What normally we do is put a superscript, let's say superscript A and superscript A here. And put a footnote. The A refers to pairwise difference. So superscript A going to indicate pairwise difference. Okay, now look at the objective. I didn't do for gender because obviously one is more than the other. So this is the test association between QL demographic, 2 levels, okay, t-test. But more than 2 levels, we use one way ANOVA. Just call it one way ANOVA, right? So now the p-value says significant difference. Who is different? Which pair is different? From the post-hoc analysis, we found these two are different. I mean, right inside here going to be messy. So put a superscript, whatever symbol, whatever, right? So the person reads there, hey, what is A? What is A here? A refers to pairwise difference. Between what? Between primary and tertiary. Are we clear?
Yes, Prof.
Right. Next one. Next for psychological. Which groups are different? Psychological. Who's different? Who's different? Right, example, okay. Supposing the values are like this. Supposing, it's not correct value, okay. Supposing values are like this. So who's different? Which pair is different? Subset 1. Who is in subset 1?
Tertiary.
Tertiary. Who is subset 2? Who is subset 2?
Secondary and
Secondary and
primary.
so what differ? How many pairs are different here? How many pairs are different? Just now, how many pairs are different? This and this, only one pair, right?
Yes.
Now, how many pairs are different?
2.
Sekolah menengah and tertiary, sekolah rendah and tertiary. 2 pairs are different. So back here now, tertiary differ from primary, is already there. Now another subgroup, another pair, this secondary also differ from tertiary, right?
Yes.
So to differentiate, I put a B and B here. All right. So now A, B indicate there's a pairwise difference. When a person reads this now, you're testing education versus psychological domain. p-value less than 0.05, that means at least one pair is different. Superscript A belongs to primary and tertiary. Superscript B belong to, superscript A belong to primary and tertiary. Sorry, wrong place, huh? This must be here. Superscript A refers to primary and tertiary. B refers to secondary and tertiary. Are you okay with this?
Yes.
Right? Let's try next one. That's the same. Supposing the values are here. Is it similar to just now?
Yes.
Yes.
So what's different? Same thing here. Tertiary differ from Menengah and rendah. So A refers to primary and tertiary. B refers to secondary and tertiary. And that's what the footnote here, what A and B stand for. Environment. How does environment work? How's environment? Which pairs are different? Who's different?
Tertiary and primary different, and then secondary and primary different.
Right. So tertiary and secondary, no difference, right?
Yeah.
So primary differ from tertiary, right?
Tertiary.
Okay, primary differ from tertiary. Now where does the B go? Between primary and secondary. Check, is it correct? A refers to
Tertiary and primary.
tertiary and primary. B refers to,
Secondary and
Second.
primary.
all right, secondary and primary. So for all the variables, you're going to do exactly the same. Just two, maybe t-test. More than two, basically it's one way and over, but it can't do because they are string variables. So we opted to that multivariate. Are we clear?
Yes, Prof.
Yes.
Okay.
Yes, Prof.
Supposing, after doing everything, only this is all the rest supposing not significant. Supposing all the rest are not significant, right? So how to express this now? For physical, the mean score for females is more than males, right? In terms of education, there were significant differences in all 4 domains. Right? In terms of education, all 4 domains. How to explain? For physical domain, who's lower? You can talk about lower or higher. What's the difference? The mean score for those with tertiary level of education was lower compared to those with primary level of education. Right. The next one, psychological. Okay, for psychological domain, the mean score for tertiary significantly lower, right, to with the primary or secondary level of education. Okay, you do this, that answers your objective number 2. So this is a template like, practice on it. When actual data is given to you, shouldn't be any problem, just fill it up. Questions?
No questions, doctor.
All right. So you covered obesity, QOL. So QOL and happiness, one more level to measure happiness score, then you're done. Those happiness, very simple, straightforward. I think we do the happiness and stop, okay, for afternoon. Between the mental health and happiness, I think happiness is very simple, straightforward. So far, any questions? So you don't analyze it, save the, no need. Do the analysis and complete straight away. And you're done. We don't want all this table copy and paste. Some students just copy and paste all the tables for what? Right? They paste this table, so many tables. We don't want that. Now, we don't want to use this procedure, which I use just now, right, to compare the 4 domains between groups. I can use either normally use one way ANOVA, right? One way ANOVA. But tahap pendidikan, it was defined string variable, so you can't put a string variable here. That's why I opted to this analysis, but don't call it multivariate. Don't call it multivariate. Still one way ANOVA. If it has obese 3 levels, I can put here. The obese also can go here because obese is defined numerically. Since obese can go here, whatever can go here, use for simplicity purpose, use ANOVA. Whatever can't go here, use this procedure. So if I follow this for obesity, I go to options, ask for descriptive. That's not same. I go to EM means, sorry, I go to options, ask for descriptive. Same thing. Let's say run this analysis for obese group. Are they different? Look at the ANOVA table. Any p-value significant?
No.
No. That means what? There's no significant difference in mean scores between the 3 obese levels. I'll show you with the multiple analysis now whether these scores, how they differ from the other, whether they differ from the other. Right. So this one I got from ANOVA table. Okay. Our main thing is only this. Okay, only this one. I'm going to delete the rest. So easier to make comparison. These p-values here from ANOVA, are they exactly same as this?
Yes.
Right. Here look at test between subject, here ANOVA table. You can see that none of them are significant. So report the mean values, and report the p-values. So p-values from the analysis. So these are p-values. So we report below, let's say example here. There's an example. Let's say this p-value equals to 0.257. P-value here, 0.125, 0. So we know all the 4 domain scores do not differ by employment status. All right. Here, what are the brackets? What are the brackets here refer to?
The p-values.
But you're not telling it, right? So values in parentheses or brackets are the p-values. Oh. So when I read this, what is the parenthesis? What's the bracket one? There are p-values or p-value. You're telling the significant and say male and female are different. Here telling the p-value less than 0.05, that means that's a difference. Who is different? You're putting A, so this pair is different. A and the B pairs are different. So easier to interpret. Are you okay?
Yes.
All right.
Yes.
Later, this is already chapter 4. Chapter 5, what are you going to do? Discussion. You're going to take whatever here, copy this. Now let's say in chapter 5, discussion. Whatever finding we had, paste it here and explain. That's why I say summarizing chapter 4, what is important is very important, right? In terms of education. All right, education talking about. In terms of education, all they're different are now discussed. Who's lower? Generally, who's lower?
Tertiary.
Generally, QOL in 4 domain in the 4 domains, right? Generally, right?
Yes.
Generally, QOL 4 domains is lower among those with tertiary level of education, right? Tertiary level education. So we take it out. We brought it here just to say what is happening. And now we discuss why. Why is it possible? What does literature say? Previous studies. The previous study discussed this or not, why tertiary is lower. Supposing previous studies did not mention at all there's a difference between education levels. Only your study, there was a difference. How to explain this? This is why, if there is evidence from literature, it's fine. No evidence, then what do you do? No evidence. Why is it so? What are the possible reasons? What are the possible reasons? Come on.
Because the target population is different, the living conditions are different.
Living conditions different, but why must the perception differ by level of education? Example, environment. Why the tertiary must be lower compared to other two? Is it expectation?
Yes.
Those tertiary level education, they may expect better living conditions compared to those low education, perhaps. But use the word perhaps, okay? Don't say this is true. Okay, we don't know yet. But literature support is there. This is similar to a study by XYZ. They found that those higher level education generally are lower in quality of life. But sometimes literature, they would have found quality of life among those higher level education was better. But we found it's lower. Again, either way, you must be able to argue. There's a writing this kind of statement in chapter 4, bring it down to chapter 5, and just summarize it. Don't copy and paste again, okay? Just summarize this and go on telling why. Is it similar to other studies? Is it different from other studies? No study done in this area before. So what does it mean? Are we clear?
Yes.
All right. So this group and quality of life should be able to complete within 1 hour once you collect the data. Can write?
Can.
1 hour can write? Can or not? Okay, 1 day. Okay, 1 day can or not?
Yes.
Syntax is there, just the whole thing is there. Next, you want to compare? Okay, whether t-test or what? Just do it. And whatever results, take it up chapter 5, put it there first, understand this, and then generalize it. Right? Then you're done. All right, questions? 12:45. Questions?
Prof.
Yeah.
I'm Euro from batch 18 and I have a question regarding to the test to be